Imagine for a second, just picture this. A hospital's brand new artificial intelligence system suddenly denies you a life-saving medical procedure.
Oh, wow. Yeah, that's a nightmare scenario.
Right. So naturally you panic. Your doctor sits down at the terminal, types in a manual override command, and basically asks the system to explain its reasoning.
Hoping for some kind of medical justification.
Exactly. But the machine simply outputs error. Logic not found.
Oof.
Yeah, there's no appeal, no explanation, just a literal black box that holds your life in its hands.
Which is terrifying.
It really is. So today, we are prying open that black box. Welcome to this deep dive.
Glad to be here.
We've got this stack of incredibly dense, but absolutely vital source material sitting right in front of us. It outlines the 8 core principles for responsible AI design.
Yeah, and when you first read through a list of ethical principles like this, it can definitely sound like a corporate PR strategy, right?
Oh, totally. Like just legal jargon to avoid getting sued.
Exactly. But looking closely at the engineering requirements outlined in our sources, these aren't just vague suggestions. I mean, they are the literal structural blueprints for how these systems actually function.
Okay, let's unpack this. Because our mission today isn't just to rattle off a list of nice-sounding, corporate buzzwords.
No, nobody wants that.
Right. We want to explore the actual enforceable code, the actionable guardrails that developers have to build into these multi-million-dollar systems before they are unleashed on the world.
And we really need to look at why you, sitting there listening to this right now, need to care about this.
Exactly. Because these invisible safety nets, they're already dictating your life. They're filtering your resume before a human ever sees it.
They're calculating your mortgage rate.
Yes. And they're curating the news you read every single morning.
The whole architecture of trust in the digital age relies on these guardrails. Because without them, the line between a helpful tool and a systemic disaster is, well, it's practically non-existent.
So true. So let's dive into the sources. They start by establishing the absolute bedrock.
Right, the foundation. Before an AI can, draft a marketing email or drive a car, it has to meet a baseline of simply being allowed to exist in our society.
Which means it has to be legally compliant. Principle number 1.
Exactly. And reading through the documentation, legal compliance goes way beyond having a lawyer just kind of glance at the final product before launch.
Yeah, it's not just a final checklist.
No, it requires embedding safeguards throughout the entire life cycle of the AI. The text specifically highlights aligning with major international frameworks.
Like the European Union's AI Act, right?
Right, and the General Data Protection Regulation, or GDPR.
But, okay, I have a question about that. How does a developer actually code an AI to follow a privacy law? Like, mechanically?
Well, it really comes down to data processing mechanisms. Let's say an AI is analyzing health records.
Okay.
Under GDPR, you can't just scrape a million people's personal medical histories and feed them raw into a training model.
Because that would be a massive privacy violation.
Exactly. The system must process that data with explicit user consent. And critically, it must anonymize it.
Right.
So in practice, engineers use techniques like differential privacy.
Differential privacy. Wait, let's drill down into that. How does that actually work under the hood?
So it essentially means the algorithm injects mathematically calibrated statistical noise into the data set.
Mathematical noise.
Yeah, like it alters the specific data points just enough so that it becomes computationally impossible to reverse engineer the data and identify you as an individual.
Oh, wow.
But, and this is the key, it preserves the overall statistical patterns. So the AI can still learn how to detect, say, early signs of diabetes across a population.
That is fascinating. So the legal requirement actually forces a specific technical mechanism. The law mandates the math.
That's a great way to put it.
But here is where I want to push back a bit.
Sure.
Because the very next principle, the sources detail, is that an AI must be fair and inclusive.
Principle 2, yeah.
If a system is strictly following the law and using that mathematically anonymized data, isn't it already fair? Can an AI be fully legally compliant but still be wildly unfair?
What's fascinating here is that the answer is absolutely yes.
Really?
Oh, completely.
No.
You have to remember, the law is inherently reactive. It legislates what has already gone wrong in the past.
Okay, that makes sense.
But fairness requires proactive design. A legally compliant AI might not violate any current privacy statutes, but it can still devastate a community because of how it optimizes its variables.
Give me an example of how that happens, because, a machine doesn't have personal prejudices. It's just code. How does it learn to be unfair?
It learns through proxy variable.
Proxy variable.
Yeah, an AI is essentially just an optimization machine. It only knows what is in its training data. Let's look at an automated loan approval system.
Okay, tracking with you.
By law, the algorithm might be strictly forbidden from considering a person's race or ethnicity when deciding who gets a mortgage.
Right, that would be highly illegal.
So the developers remove that data point entirely. Legal compliance achieved.
But the AI still finds a way to discriminate.
Exactly. Because the AI starts aggressively looking for patterns to predict creditworthiness. And it notices that people living in certain zip codes historically default on loans more often.
Oh, I see where this is going.
Right. So it begins automatically denying loans based on zip codes. But in the real world, due to decades of historical redlining.
Those zip codes heavily correlate with specific minority neighborhoods.
Exactly. The AI isn't prejudiced in a human sense. It simply found a proxy variable, the zip code, and it ruthlessly optimized for it.
Wow. So if legal compliance is just getting a driver's license, fairness is making sure the roads actually connect to everyone's neighborhood.
I like that analogy.
The developers have to actively hunt down those proxy variables.
Precisely. To meet the standard of being fair and inclusive, the development teams themselves need to be diverse to anticipate these blind spots.
That makes total sense.
They have to ensure their data sets are representative of the whole population. And they have to constantly test the algorithm's outputs against different demographic groups.
Just to catch when the math starts inadvertently mimicking historical prejudice.
Exactly. It's an ongoing process.
Okay, so let's say a development team does all of that. They build a system in the lab that is legally sound, and they've scrubbed the proxy variables so it's demonstrably fair.
A perfect lab specimen.
Right. Then they take it out of the lab and actually launch it. That introduces a completely different set of problems.
So a massive set of problems.
Which brings us to the necessity of making the AI technically robust and secure. Principle 3.
Yeah, the transition from the sterile laboratory to the messy, chaotic real world is where most systems fail. The sources break this down into two distinct engineering challenges.
Robustness and security.
Right. Robustness is the system's ability to operate reliably under unusual or unexpected inputs. Security is its ability to withstand deliberate, malicious attacks.
Let's start with security, because the text mentions a practice called adversarial testing.
Oh, yeah.
When I read that, it sounded basically like hiring a professional burglar to break into your house just to test how good your own security system is.
That is the exact philosophy. You are literally paying engineers to attack your own AI to see where the windows break.
But if the burglar is testing your house by picking a physical lock, how do you pick the lock of a neural network? I honestly have no idea. Do they just, overload it with web traffic?
Sometimes. A DDoS attack is common. But a much more sophisticated attack is data poisoning. Specifically, adversarial pixel perturbation.
Okay, you're going to have to explain that one.
Imagine an autonomous vehicle approaching a stop sign.
Got it.
To human eyes, the stop sign looks completely normal. Red octagon, white letters. But an adversarial tester has subtly altered a few specific pixels on the surface of the sign.
Like painted over them?
Maybe with a tiny sticker or digital static. Changes so minute that a human driver wouldn't even register them.
But the AI's computer vision sees it differently.
Completely differently. Those altered pixels exploit a specific vulnerability in the AI's image classification model. It causes the car's system to interpret that stop sign as a 65 mph speed limit sign.
Oh, wow. Wait, really? That is absolutely terrifying.
It is a critical, life-threatening vulnerability. So developers conduct adversarial testing, intentionally creating these poison data inputs to train the AI to recognize and ignore them.
So that builds the security side of things.
Right. But then you have robustness, which is about surviving the unintentional chaos of the world.
So what counts as an unintentional, unexpected input? Because, these models are trained on billions of data points. Haven't they seen practically everything by now?
They've seen massive amounts of normalized data. But let's stick with the autonomous vehicle example.
Okay.
In training, it analyzes millions of hours of perfectly paved roads, standard pedestrians, normal weather.
The easy stuff.
Yeah. But what happens if, say, a flatbed truck on the highway suddenly spills a massive load of retail mannequins all over the asphalt?
Oh, geez. The AI has definitely never seen a pile of plastic limbs on Interstate 95.
Exactly. The AI's computer vision relies on bounding boxes and confidence scores.
What does that mean?
It draws a digital box around an object and calculates, I am 99% confident this is a pedestrian, or I am 95% confident this is just a shadow.
Oh, I see.
So when confronted with disembodied mannequins moving at high speed, the confidence scores just plummet to zero. The system encounters an edge case it literally cannot compute.
And if the system freezes up in that moment, people get hurt.
Which is why the principle of robustness dictates that the system must fail gracefully.
Fail gracefully.
Yeah. When the confidence threshold drops below a certain mathematical point, the system triggers an immediate fail-safe. It either safely hands control back to the human driver, or it executes an emergency stop protocol.
So robustness means the system knows its own limitations in real time.
Exactly. It knows when to give up.
Okay, so the backup kicks in, the car pulls over, and a disaster is averted. Thank goodness for fail-safes.
Right.
But if the car had to use its backup, or worse, if the fail-safe didn't work and the car crashed, we immediately run into a major issue. We need to know why the primary system failed, and we need to know who is responsible for the damages.
Which moves us out of the realm of pure software engineering and into human oversight.
And that brings us to a trio of heavily interconnected principles from the sources. AI must be transparent, it must be explainable, and it must be accountable. Principles 4, 6, and 5.
Yes, the oversight triad.
Here's where it gets really interesting, because I've heard those terms thrown around constantly in the news, and looking at the text, I have to admit, they sound like synonyms.
They really do.
Right. Aren't transparency and explainability the exact same thing? If an AI company is being transparent, aren't they explaining how it works?
It is easily the most common point of confusion in the entire field. But functionally, technically, they are entirely different mechanisms.
Okay, break it down for me.
If we connect this to the bigger picture, think of it like going out to a restaurant.
A restaurant, okay.
Transparency is the menu and the open kitchen. You know you are at a restaurant, you understand their general purpose is to serve Italian food, and you can generally see the chefs working back there.
So in AI terms, transparency is simply knowing you are interacting with a machine and understanding what it's broadly supposed to do.
Right. Like an online recommendation engine telling you, we are showing you this sci-fi movie because you previously watched a documentary about space.
Got it. It's transparent about its broad purpose. It's the what.
Exactly. Now, explainability is the granular why. It's not just seeing the open kitchen. Explainability is the chef walking over to your table and breaking down the exact chemical reaction of the yeast in the specific slice of pizza you are currently chewing.
Oh, wow. That makes perfect sense. Transparency is the broad stroke. Explainability is the exact mechanism.
You nailed it.
And the text emphasizes that explainability is critical for high-stakes trust. Going back to our opening medical diagnosis scenario, if an AI tells a doctor a patient has a rare disease, the doctor cannot just blindly trust a black box.
They absolutely cannot. But the problem is algorithmic opacity.
Algorithmic opacity.
Yeah. Deep learning neural networks consist of millions of weighted connections. The AI doesn't think in English. It thinks in incredibly complex mathematics.
So you can't just ask it, hey, why did you decide this?
Exactly. So developers have to build separate explainability tools, like decision trees or feature importance maps, that run alongside the neural network.
Ah, tools that translate the math back into something a human doctor can actually understand.
Right. The explainability tool must point the doctor to the exact pixels on the patient's X-ray, or the specific anomaly in the blood test that triggered the mathematical threshold for that diagnosis. It forces the machine to show its work.
I love that. Show your work, just like in high school math.
Exactly. And that directly sets up the fifth principle, accountability.
Right, because if the diagnosis is wrong, you can't exactly sue an algorithm.
Accountability is the who.
Yeah.
It is explicitly assigning human responsibility for the machine's outputs.
It stops people from just pointing at the computer and shrugging.
Exactly. The documentation notes that an accountable system requires massive, detailed logging of every decision the AI makes, coupled with periodic, mandatory human audits.
So there's always a paper trail.
Someone, whether it's a developer, a corporate officer, an auditing board, someone must be the human being left holding the bag.
Okay, let's zoom out a bit and look at the whole picture we've painted. We've established a legal baseline. We've forced the system to actively root out mathematical bias.
Right.
We've built it to survive adversarial attacks and chaotic edge cases. And we've pried open the black box to guarantee human oversight. It feels like we've engineered a profoundly safe tool.
We have. It's an incredible achievement. But the final two principles in our sources force us to step away from the keyboard entirely. Yeah, they force us to ask a structural, almost philosophical question. Who does this massive system ultimately serve? And what is the physical cost of keeping it running?
Which introduces Principle 7. The mandate that AI must be human-centric. The core philosophy here is that these systems must be designed to augment human agency, not entirely replace it. They should support our decision-making.
It's all about optimizing for human well-being rather than just raw efficiency or, corporate cost cutting.
The documentation points to education as a prime example of
That's
this.
a great
A
example.
non-human-centric design would be like a tablet that lectures a child, grades their tests, and completely replaces the teacher. It's cheaper, it's efficient, but it isolates the student.
Exactly. Whereas a human-centric AI platform maps a student's individual learning speed and their specific blind spots, and then feeds that granular data back to the human teacher.
It augments the human connection instead of severing it.
Think about social media algorithms, too. For years, many platforms utilized wildly non-human-centric AI.
Oh, don't get me started.
Right. The algorithms were mathematically optimized solely for engagement, which usually just meant prioritizing outrage and anger because those emotions keep users scrolling longer.
It optimized for screen time, totally ignoring human well-being.
Precisely. A human-centric algorithm would be engineered to balance that engagement with content diversity and factual reliability, consciously prioritizing the user's mental agency over the platform's ad revenue.
It is a fundamental shift in what the AI is told to value.
It really is.
And that leads us to the final principle, Principle 8, which deals with the reality of maintaining all this technology. Responsible AI must be environmentally sustainable.
The ecological footprint.
So what does this all mean? I think this is where the public perception really diverges from the engineering reality. We hear phrases like cloud computing, and we picture something, I don't know, ethereal, just beta floating invisibly up in the sky.
Yeah, the cloud is actually just a massive, incredibly loud building in the middle of a desert.
Right. Training a large language model demands physical infrastructure on an almost incomprehensible scale.
Massive scale.
Warehouses packed with graphic processing units running at glistering temperatures. They draw staggering amounts of electricity from the grid, and they require millions of gallons of fresh water just for the cooling towers.
The ecological footprint is immense, and this presents developers with a profound irony.
An irony.
Yeah, we theoretically possess the capability to build a highly advanced AI that could help solve climate change.
Oh, I see.
It could optimize global shipping logistics or discover new materials for hyper-efficient solar panels. But if the computational power required to train that AI relies on burning thousands of tons of coal.
The tool defeats its own purpose.
Exactly.
So how do developers actually code for sustainability? I mean, is it just about buying carbon offsets and feeling better about it?
It has to go way deeper than that. Organizations are required to source renewable energy for their physical data centers, yes. But computationally, they have to build leaner models.
Leaner in what way?
They are actually using AI itself to comb through massive software architectures to identify redundant code. By streamlining the software, the processors do less work
Which means they draw less power.
and require way less water to cool down. It is using the tool to sharpen itself, minimizing the physical cost of our digital ambitions.
Wow. It is incredible to see how physical the digital world actually is.
It's all connected.
So, looking at the entire journey you just took through these source materials, the most vital takeaway is that these 8 pillars of responsible AI design cannot exist in a vacuum.
No, they are a package deal.
You cannot just pick and choose your favorites. You can't deploy a legally compliant, totally transparent system that is also an environmental catastrophe.
Right.
And you can't build a hyper-robust, secure system that optimizes for proxy variables and discriminates against entire neighborhoods. Evaluating AI requires looking at all 8 of these guardrails operating simultaneously.
They're deeply, inherently interconnected. But, as we finish up this deep dive, there's a fascinating tension between two of these specific principles that is really worth lingering on. Yeah, a structural paradox for you to chew on.
Oh, lay it on us. Where do the rules break down?
Think about the clash between the mandate to be human-centric and the mandate to be technically robust.
Okay.
We just discussed how a human-centric system is explicitly designed to support and ultimately defer to human agency. It exists to serve human choices.
Right. It doesn't replace the teacher or the driver.
But we also know that the real world is chaotic, and humans themselves are incredibly messy, irrational decision makers.
We are absolutely the most unpredictable variables in any data set.
We really are. So what happens when human agency, our own irrationality, our own right to make a terrible mistake, is the exact unexpected input that the AI has been robustly secured against?
Oh, wow. I hadn't thought of that.
If a human driver demands that an autonomous vehicle execute a maneuver the system calculates is highly dangerous. Does the human-centric principle dictate the AI must defer to human agency and allow the risk?
Or does the robustness principle dictate the AI must lock the human out of the controls to prevent a crash?
Exactly. Do we eventually have to choose between an artificial intelligence that perfectly supports our freedom to make mistakes and an artificial intelligence that perfectly protects us from ourselves?
That is the ultimate edge case, and it brings us right back to that opening scenario in the hospital. We all want the clean, binary answer. We want the technology to flawlessly optimize our lives.
But humanity isn't binary.
No. When you are engineering a system to navigate the gray areas of human existence, the simple math breaks down.
Yeah.
You are left trying to balance legal requirements, robust safety features, environmental realities, and what it actually means to maintain our own agency.
It's a massive balancing act.
It truly is. Keep an eye on those 8 principles as you interact with these algorithms every single day, and as we all figure out how to build this architecture of trust without getting completely locked out of the house. Thanks for joining us on this deep dive. We'll catch you next time.